wind. Okay, before that, I think we have discussed, no, if the, let me take this one. If the velocity of observer like this, making an angle. Okay, did I discuss this yesterday? Anybody? Okay, no, let it be, let it be. Once again, I'll put it. Okay, there's a speed of velocity of observer, and so they are moving. Let's calculate even the wavelength also. In this case, how the wavelength will be. Apparent frequency will calculate. Now look at the observer and the source. They are moving in some plane. They're moving in a plane. First, we'll calculate the apparent frequency. The source will generate a signal at a frequency f. It will be detected at f dash. Okay, I agree this one. Now, what is the first apparent frequency we'll calculate it? So that the apparent frequency will be given by f dash is equal to f dash, or any other symbol you can prefer. F dash should be equal to v plus v naught cos alpha by v minus vs sin beta into f. Okay, I think this everyone knows. So this is what apparent frequency. Now, what about apparent wavelength? With what speed actually the wave? So what is v? Speed of the wave. Now, with in what direction the waves will approach, like this here in this direction. So therefore, what is the apparent frequency? No, this will be apparent wavelength. Lambda dash should be equal to v relative by f dash. What is the relative motion between the person and the wave along line joining? V naught, v plus v naught cos alpha by f dash. What is f dash? V plus v naught cos alpha by okay, this is the apparent wavelength. Or wavelength of the waves received by the observer. Okay, very simple idea. Not only just moving in same direction, moving in any arbitrary direction also, we can just bring the concept of this apparent wavelength. Any doubt you can clarify, and I'll go for the next set of numericals. Doppler effect, very simple. Only you have to understand that initial conditions. Rest all applications are very, very easy. You can manage very comfortably. Let's take the effect of wind. If the wind blows, there's a source, there's an observer. Let the source move with a velocity v1, v2. The wind blows in this direction, and the speed of the wave, speed of the sound, let it be v. This will generate frequency f. F dash I'm going to here. What are the symbols like? V1, V2. We have symbols, no? First we'll define them. This is speed of source, speed of observer or detector. Next, speed of wind. Wind, no, the wind will blow, and this is speed of sound. Okay, these are the symbols are there. What about the apparent frequency and apparent wavelength also? I'm interested. Okay, how to bring the wind is blowing from source to detect. It can blow it any direction. No? The wind can blow in any direction. Now, what is the medium? The medium will be propagating. No, are you able to understand? The medium itself will propagate. No, the effect of wind will be there. So now first we'll get into velocity of sound with respect to medium is equal to velocity of sound with respect to ground minus velocity of wind with respect to ground. This is nothing but VW G, and this V is nothing but velocity of sound with respect to ground. Let's have clarity with the symbols what we have. Okay, this I can write it in what direction. I don't know velocity of sound with respect to ground. That has to be determined. Velocity of sound with respect to wind. What shall I write here, that one? Okay, this is velocity of sound with respect to wind it is. Because it'll be propagating in medium, no? And the medium is propagating this one. So this should be equal to what we have V. This is we don't know. I'll write it, let it be. Towards right, no? It will be. And the wind is blowing towards right. So therefore this will become V plus VW equal to this one. What is VSG? Velocity of sound with respect to ground. Now the apparent frequency, I'll put it. So F dash should be equal to, now what is the velocity of the sound with respect to ground? VSG, and the observer is approaching it. The source is approaching the observer, so VSG minus VN. What is VSG? We have a formula. So this will be V plus VW minus or plus V2. Try to see this. This is very important. You have to substitute the effective speed of the wave. What is we know? Speed of the wave with respect to ground it will be, because with respect to medium, because the wave sound wave will propagate, it will propagate in the medium, no? And what all you measure it is with respect to medium. So what is V given, that will become with respect to medium. In the Doppler effect, what are V1, V2? Speed of source and observer with respect to ground. Even in the formula, the speed of the sound with respect to ground has to be substituted here. Sir, if the wind blows towards left, okay, it will become V minus VW. What is the apparent wavelength? The apparent frequency. Apparent wavelength also will calculate. Lambda dash. What shall I write with lambda dash? The speed with which the waves strike the observer. What is the velocity of the wave? because there won't be impact of wind on the person. Where the wave will be moving in the medium. So what is the relative motion between the wave and the observer? So V relative is what? I'll directly get into and F dash. What is V relative? What do you mean by V relative? Velocity of the wave with respect to observer. So how to calculate this one? V relative equal to velocity of sound with respect to ground minus velocity of observer. What is velocity of observer with respect to ground? Velocity of sound with respect to ground, we know V plus VW minus velocity of observer with respect to ground minus V2. Please look at the symbols, very important. What is V relative? Velocity of wave with respect to observer. Okay, got this. So that I'm going to substitute here. So this will become V plus VW plus V2 Getting the idea? This one. So like this, what will happen? All things with the basics, what we know, with that only what happen, we are managing. Nothing big. If the wind blows towards left, what you are going to do? Where all VW is there, you are going to put negative sign. Here you are going to put negative sign. Here, what all you get, that you are going to substitute. So here what I took is anything directed towards right is what? Positive. Okay, this will be the effect of wind. Okay, now let's take the another situation. If the source and is the observer, both are at rest, and the wind is blowing like this. The signal will be generated at a actual frequency f. At what frequency it will be received? What is VW? VW is the velocity of wind. And what is V? Velocity of wave with respect to wind. Velocity of sound wave. Again, wave means you think some other thing. Velocity of sound wave with respect to wind. Okay, let's discuss now. First, what is apparent frequency? Okay, again, we should know velocity of the wave with respect to ground, no? Velocity of wave. So this is like a velocity of wave with respect to wind, velocity of sound wave with respect. I think the symbols little bit confusion, try to manage. Velocity of sound wave with respect to ground. This is also equal to VSW. Am I right? No. Equal to velocity of wave with respect to ground. Velocity of sound wave with respect to wind is what V. Velocity of sound with respect to ground, we don't know. That of the wind is VW. So as usual, V plus VW equal to. Let's come for Doppler effect formula. F dash is equal to. What is the velocity of the sound wave with respect to ground? Velocity of the observer, 0. Plus or anything you write it. Velocity of sound with respect to ground plus velocity of source. It's also 0 into F. So finally what we are getting? F only. Both will cancel out. So at what frequency the signal is generated, at the same frequency we are going to hear it. That's the one thing. Okay, keep it here now. What about the wavelength? Let's see wavelength here. Now lambda dash is equal to first relative. What is relative? Velocity of wave with respect to observer. Velocity of wave with respect to ground. Velocity of sound wave with respect to ground minus velocity of observer. Velocity of sound with respect to ground is how much? V plus VW. Velocity of observer, it is at rest. Then what is lambda dash is equal to the speed of the wave with respect to observer by apparent frequency. What is V relative? V plus VW. But what is F dash? Is F. What is actual wavelength? Actual wavelength, if the wind doesn't blows, it will be V by F. Because of the wind, what happened? It is V plus VW. So that the apparent frequency is equal to actual frequency, but the apparent wavelength is not equal to actual, like a actual wavelength. Suppose the wind doesn't blows, VW you put it 0, V by F would have been the wavelength. I think the mathematics is very important. The terms are very important here. If the wind doesn't blows, the speed of the wave with respect to ground will be equal to V. That was the method what we used. And what is relative? Velocity of sound with respect to observer, it is the meaning of this one. Okay, I think very simple analysis. You can manage. Huh? Some good thinking is needed. So what is the good thinking? The thinking should be there of this kind. This is very important. This is very important. Any doubt if you have, you can clarify here. Okay, now we'll take the Doppler effect in the reflection.